I'll go ahead and answer this question. This is what I'm about to tell you is a way to make your calculator solve almost any equation you ever have. How does that sound, guys? Does that sound neat? Yeah, maybe. I don't know, Jeff. You got to show me what the hell you're talking about. All right, let me open my calculator emulator. Calculator emulator. So this is related to number 48. And you said 6.2, right? Tell me I'm looking at the right one. Five, 51, 6.2. All right, I will in a minute. Faye, was it your question right? Please tell me I'm in the right section. 6.2, number 48?
Yes.
Okay, thank God.
Yes.
So let me show you something neat. All right, now watch. I'm gonna write on top of this. This is gonna be a little freaky, but let me give us an equation to work with. All right, let's say I want to solve the equation. Oh, where can I put this? Oh, screw it. I'll just put it over here. Say I want to solve the equation 3 plus 4.2 to the x equals, let's see, we should probably make something that has an answer. That would probably be good. Sure, equals 5x plus 3. Okay, let's see. I don't know. Let's all find out if this has an answer. Yeah, it does. It has too easy of an answer, actually. Wait a minute. Let me see. Yeah, let me do this. Make that 2. All right. That answer was too easy. Make that a 2. Okay, now, this is kind of cool. Think of this as, so think of this graphically. I'm going to think of solving this equation graphically. Okay, I can't let go of this. Gross 2. All right. If I graph this, if I graph y equals this, and I graph y equals this, graphically, where will the answer to this equation be? Where each graph does what? Where the graphs do what?
Is it where they would intersect?
Where they intersect. That's the one point where the outputs are equal. So that would be the answer to the equation. And of course, some equations could have more than one answer. Like you could have a circle and a parabola, and there could be multiple, pretending that's a circle for one point, but there could be multiple points of intersection. It could be multiple answers. So let's see. Let's go to y equals. All right, this could get a little bit funkadelic. Of course it is. And I'm going to put in there 3 plus 4.2 to the x. 3 plus 4.2 to the x. And then here I'm going to put 5x plus 2. All right, let's see if Jeff made a problem that has an actual answer. Wouldn't that be nice, kids? All right, let's try to graph this. Oh, crap. I'm in some weird. Yeah, okay. This is good. I'm in a really weird window, but I can see it looks like they probably have at least one answer there. So let's do, I do zoom 6 is a great thing to do. Standard window. All right, so now I can kind of see, oh, maybe they have, all right, maybe I picked poorly. It looks like they might have an answer here. Do you guys see what I'm saying? They might have an intersection there. So how do I do this? I do my favorite thing. I get to do my zoom box. Okay. So what I'm going to do is I'm going to take the cursor to one corner of a box and then open it around the area I want to enhance. All right, let's see if these actually intersect. Ah, of course, Jeff. Oh man. Well, at least now I know they have no solution. Dadgummit. So let me fix this a little bit. Everybody just deal with Jeff trying to make a problem on the spot here. I should have went the other way with this. I should have made this 4. So that the original equation I gave actually has no solution. There is no way to do it by hand. Well, let me be careful. There is a way to do it by hand, but it's unbelievably disgusting. There's no good way to solve this equation by hand. But if I go back, let me change the second equation to +4. Now you should understand why there's going to be at least one answer, because I've raised the line up a little bit. Now there should be at least one answer. And of course, it's off the screen. I love it. Things are going great. Let me go back to Zoom window like this. All right, now I can see one answer right there. And then there's going to be another answer a little bit further up. So how do I find, let me find the a little bit further up answer. That looks a little more interesting. So let me go up a little bit. I'm going to make my Y max go to 15. So I can go up a little bit. And now I can see it. See, I can see the intersection. So guess what I'm going to use? Guess that I'm going to do calc. I want to graphically calculate something. Every button up here has to do with graphing. Kind of the giveaway is the big graph button, but every button up here is about graph stuff. So I want to calculate something graphically. I obviously want to calculate the intersection graphically. And they're going to ask me 3 very familiar sounding questions. Well, actually, I forgot about this. They're going to ask me 3 questions. First curve, so I'm going to make sure I'm on the blue line. Second curve, see how it bounces to the red line? And then it's going to ask me for a guess. So I'm going to put my cursor right about where they intersect. And then there's the answer to the equation. Why do I not care about this? Is that a part of my equation? What does my equation care about?
The value of x.
The value of x that makes these equal. They both happen to be this number, but the equation doesn't give a shit. It just wants to know what value of x makes these equal. So that's the value of x that would make these equal. You can solve any equation that you can graph in the calculator. Can you graph every equation in the calculator? No, not easily. But any equation you can graph in the calculator, you can do this intersect thing by graphing each side of it and seeing where they intersect. Then you get the answers. It's crazy. So every equation you've ever solved, more than likely you could solve this way as a way to check your answer. Isn't that awesome? You're all like, well, what the shit, man? Why didn't you tell me that on the first day? Because I want you doing most of your stuff by hand for sure. So now you have one more way to check stuff. Is that all right? Does that make sense? That is how you do this one. Let me show you again. So the question was about number 48 and 6.2. That's how you do this problem. So you graph 12, make y1 equal to 12, and you make y2 equal to this. All right, go away. Stop. Stop it. Stop doing weird shit. Oh, man, I tell you. Stop it. Go away. Crazy. All right. So you put this on y1, and you put this in y2. And then you do the intersect. Like I said, you might have to move the window around a little bit to see where they actually intersect. But once you see it, you can use Zoom box if you want to and enhance like you're on CSI or whatever the shit you like, NCIS. I don't know, whatever the crime shows are. Bong bong. Okay. Is that all right? So understand, it doesn't just work here. It works with any equation that you can graph in the calculator, both sides. It'll solve them for you. It's crazy. All right. I'm not getting the reaction I wanted, but that's okay. And, I mean, that's should be like, oh, well, shit, yeah. I can check almost any damn equation I ever do. Thanks, Jeff. All right. Anything else from homework stuff? I think there was something in the chat. What did I miss here? Oh, 6.2, number 51. Okay. Explore and discuss. I think you gotta love this. This sounds really interesting. The graphs of b to the x and 1 over b to the x. So how do you do that? In your calculator, graph 5 to the x and 1 over 5 to the x, and then just see if there's any connection. Then do 4 to the x and 1 over 4 to the x and 3 to the x and 1 over 3 to the x. And just, is there a connection between them? Is one the other one flipped? Is one the other one moved over by 7? Is, you know, does that make sense? See if there's a connection between them. Is there some graphical similarity? Is one the mirror image of the other one? That kind of thing. So what's weird about that problem is you don't realize you're allowed to do that. That's what they mean by explore. put stuff in for this thing and look what happens. That's another way to say explore, right? I like it. You're like, what am I supposed to do? Let me explore. Here I am at the F. And then we move over to the X. No. It's a very boring Animal Planet kind of thing for math. And then we look around the corner and there's a B. Not that kind of B. All right, sorry. Oh, I'm tired. This is going to make me even goofier than normal. I'm sorry. Anything else? Any other questions from homework that I can make a pretend TV show about?
Just a really quick question. On the calculator, what did you put for the intersect?
So to find the intersection, let me do it one more time. So go
Yeah.
to second calc, or trace really. You have to do second to get to calc because I want to graphically calculate something. Remember, we've been in here before, I'm pretty sure, to find the minimum and the maximum. Remember that way I had to do the left side and the right side and then do a guess. So now you would just go down to intersect and you're going to tell it. Now here's the neat thing. Do you see how it's on the blue line right now?
Yeah.
All right, so it wants the first curve. And now watch what happens when I hit enter. See how it bounces to the next curve? And so the question now is second curve. I'm like, all right, you already bounced to the second curve. I'll just hit enter. And then the last question is guess. So let's find this other one. It looks like it's going to be 0, 4. So bam, it is 0, 4. Ooh. 3 would have probably been fine, Jeff. I don't know. These things happen. I don't know. This is neat. I'm not sure why it's green. Does that look green to you guys? I don't know. It's weird. I don't know what it's doing. Poor little dude. So one more time. Calc, intersect. Let me find the other one. Watch what I can do. You ready? This is what I always do. I put the cursor as close as I can. I hit enter, 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 and I'm done. Because first guess, when you hit enter, it bounces to the next line. Enter, and I'm already on top of the guess. Enter. So if I just put my cursor on top of the intersection, enter, enter, enter. Bam. And like I said, there could be multiple answers to a problem, especially when your functions, at least one of them is curvy. If both of them are curvy, screw it. There could be a ton of answers, right? Okay, maybe. Now I am calling a circle a function. It's not a function, but you get what I mean. You could graph a circle in the graphing calculator, but you have to use 2 equations to do it. So we'll talk about circles later this semester, don't worry. Anything else, homework? By the way, guys, I was so focused on the midterm coming up, but what is happening on Thursday?
A quiz.
A quiz, yeah. You're like, what the shit? But I hopefully some of you guys, I don't know how new everybody is. I know a few of you guys have been in college for at least a year, if not more. You should know by now that the more grades you get, the better. You want more grades. So I had a class where the only grade was the oral final exam. That was the only grade. So a girl in the room next to me had a nervous breakdown. It was great. No pressure. The quiz is going to be 6-1 through 6-4. And here's something really nice. I don't know if you guys got a notification about this, but I put a practice quiz up in here that I want us to work on today. So if I go to 176, go to modules, become a student. Become a student. Go down to unit 6, quiz 5, practice 6-1 through 6-4. You see what's happening. I love you guys. This Thursday is a quiz. When is the midterm happening?
25th.
So a week from this Thursday is the midterm, and over the weekend, I will post a practice midterm. Right? Okay. So right now, could you please go to Canvas and get this quiz 5 practice? Please go grab this thing. I kind of Frankenstein them together for some old practice stuff. I don't know why I don't have more of this. Oh, that's right. We also have this other thing. Let's see, which one should we do first? I think we should probably do this other. We didn't do this other thing last time, did we? The, I don't know. I know at least one of you guys tried some of this out already. The properties of logs. Let's look at that first. Go here first. Properties of logs. This guy. So go get this bad boy right now. I'm going to open him a different way so I can work with it a little bit easier. But go get that. Let's take a look at this. This will be a good review of what we did yesterday. Oh, where is that? That's the next good question. Scheisse. What is that thing called? It's called, oh yeah, I know where it is. So many files. Here we go. Do I already have it open? No, I don't. Okay. All right, guys. So go get that sheet, the properties of logs from Canvas. Go get it right now. Go look at it, print it out. Don't print it out, whatever. Just have it handy. These are the properties we went over last time. So what do you do with the powers when you multiply things with like bases? You add the powers. That's what that says. Multiply means add powers. Divide means subtract powers. It's crazy. Holy shit. Now, is there any property that says anything about this? There we go. No, there is nothing for this. What do I do when I add two things with the same base? I don't do shit if they don't have the same power, right? So that's not really something I can make any generalization about. So there is no property for this. So you got to be careful. I can rewrite a single log of a product as the sum of the logs. So if the original is a multiplication, I can rewrite it as the sum of the powers. And what is a log? It's a power. Okay, I love it. So go ahead and try these out. So like you'll notice on the first problem, it's kind of like going this way with the property, right? And then these two are using it the reverse way, putting them together. So just to make sure we're all on the right track here, how do I rewrite this first guy?
Log 3 of 3 plus log 3 of x.
Yes, so I have a log of a product is equal to the sum of the logs. And what is, can I do either one of these? I don't know what the hell log base 3 of x is, but what's log base 3 of 3?
1.
Yeah, because that's the power 3 needs to become 3. I like it. All right, keep going. Oh, dadgummit. Oh, that's okay. That's all right. Oh, I see what you did. All right. I think I see what you did. Wait a minute. Why is there a 2 there? So the log base 12 of 3 plus the log base 12 of 4, I can rewrite that as the log base 12 of 12. Yes. Right?
I think they put the 2 there because it's number 2.
Oh, maybe. I think you're right. I was worried that it was there because there's 2 logs. Okay. That would have got me concerned. So I'm just doing it the other way around. So if I have the sum of 2 logs with the same base, I can combine this as a product, right? Just going backwards. When do I add powers? When I was multiplying the stuff. That's all it says. And of course, 3 times 4 is 12. And what's log base 12 of 12? Yes.
1.
I felt it coming. 1, 1, 1. I see 1 everywhere. Okay, I like it. Now, number 3 is neat. I want to show you something interesting about number 3. Believe it or not. No, Jeff, don't do that. All right, good. So if I just do this directly, what'll this be? Log base 4 of and everybody likes to chat at me. You don't like to talk to me. Okay, 12.
4.
So yeah, 1/3 of 12, right? Which is 4, which again is 1. Ooh, Jeff, way to be creative. But I want you to notice something interesting about log base 4 of 1/3. Let me take a second. Log base 4 of 1/3. Isn't that log base 4 of 3 to the -1? You guys see that? Isn't that negative? Remember what I can do with the power that's up there? I can take it down. That's the last property. Remember that? So negative log base 4 of 3. Are you with me? That's neat. That's interesting. So this becomes log base 4 of 12 minus log base 4 of 3, which is the next property, which would be 12 divided by 3, which still gets me here, right? It's got to be self-consistent. So all the properties, if you choose to use them in orders that are still legal by the order operations, it should come out to be the same answer. They have to be self-consistent. All right, so that's a neat one. If I have any log of a fraction, I can rewrite that as a negative log of the reciprocal, right? So if it's 1 over something, I can make it a nice whole number inside just by changing the sign of the log, because that negative power comes down. Okay. And just to kind of tack onto that, it kind of makes you look at this in a different light when you realize this is just this. Is that cool? Right? When that negative go up, make that a positive. And then that would be 1 over y. And then, of course, wouldn't that just be x times 1 over y, which is x over y, which is what the hell it is? Holy shit. Okay, maybe. I'm not saying this to make you more confused. Hopefully, it's not what's happening. I just want to make you see how all the properties have to work with each other. They have to make sense together, or else the whole thing goes out the freaking window. All right. So this is not necessary to do these problems. That's just a little side note. So I'm going to take that away. All right. So what can I do with number 1?
Log base 3 of 3 minus log base 3 of 5.
And log base 3 is 1 still. And there we go. I'm done. And again, you're not as used to logarithms. So if you're sitting there trying to say, does that make sense? You're not going to know. It's sort of like saying, does that look about 4 decimeters away? And you're like, I'm American, man. We're all dumb. We don't use metric, so I have no idea. I wasn't brought up in decimeters. I have no idea what a decimeter is. So logarithms, we don't use them much. So you're not going to have an intuitive sense for if an answer for a logarithm makes sense. Not yet, anyway, right? So you look at that answer, you're like, okay. I mean, there's no way to look at it and goes, yeah, that makes sense. You can't do that because you're not used to logarithms. What is one thing that makes sense? So hopefully this makes sense. Isn't the inside less than 1? Shouldn't this answer be negative? Wouldn't it be take like 3 to the negative 1 would be 1/3. So I could do 3 to a negative power to make it become 3/5. It's going to be some kind of a negative power, and 1 minus log base 3 of 5 is definitely going to be negative. Okay, I'm going way too far here, and I'm really sorry, but I'm just trying to give you a little bit of a feel for if this answer makes sense. What's log base 3 of 3? What's log base 3 of 3 is 1, correct?
Correct.
Log base 3 of 5, how is that related to 1? Bigger or smaller?
Bigger.
It's got to be bigger because 5 is bigger than 3. So 1 minus something bigger than 1 is negative. So it will be a negative power, like I could kind of tell it should be, to make it become fractional. Now that still is foreign to us, but I'm hoping I don't know if anybody was thinking this way at all, but I know some of you guys are looking at it and thinking, I can't tell if that is something I expected. I can't tell if that makes sense. So there's a couple of ways you can kind of make sure it kind of makes sense if you want to. How do I do number? Sorry?
Can you put a different base in a calculator when calculating a log? Can you put log base 3 into a calculator?
We got to talk about that. We're going to talk about that like very soon. So I think as soon as we finish the practice quiz sheet, I want to do something called the change a base formula. There's a way to change the base to any other base you want it to be.
Okay.
Which is exactly what you're kind of asking for right now. Yeah, so somebody's already, I almost said tweeted this to me. Somebody's already chatted to me what to do here. What would I do here, of course?
75 divided by 3.
Yeah, so since it's subtraction, it's going to be a division inside. And of course, 75 divided by 3 is 25. And look at Jeff has really stepped up the game. The answer is not 1 now. The answer is 2. Holy shit. Okay. And again, it's because 5 needs a second power to become 25. You can always do these arrows. 5 needs this power to become that thing. What does this poor little dude here mean? Does he have a base?
It's 10.
Good. So if the base is not showing, it's just like square root is understood 2. A log without a base is understood 10. So can somebody just tell me what that is? I've no real
Negative
idea.
1.
Yeah, you already know it's negative 1. But another way to get that answer, did somebody get it a different way? Let me see. Somebody's telling me the answer is 1. That's not good. Okay. I could also do it like this. Log 1 minus log 10. What's log base anything of 1?
0.
Good, because anything needs a 0 power to become 1. And what's log base anything of itself? 1. And what's 0 minus 1? Negative 1. Yay! So it still works, but I didn't need it because 1/10 is just the reciprocal of 10. So I knew it was a negative 1 power already. I didn't need a quotient rule to help me. Okay. And then we have good old plog. It's plog. It's plog. All right. So this is the one where somebody got that. Like number 1, what's the little thing I could do with number 1 here?
Take the 2 to the front.
Yeah, I could just take the 2 down. So that's amazing. So, I mean, sometimes it's better to have the 2 out front, and sometimes you'll actually do the reverse. You'll take coefficients and put them back up in the power. What the hell do I do in number 2?
Isn't it just to the, what is it? isn't the square root at was it -2 or something like that?
1/2.
Yes, because what's a root do? It cuts something in half multiplicatively, a square root does.
That's what I meant.
You're good. You're all right. So the root is on the bottom and the power is on the top. So if I had like the cube root of x squared, that's the same thing as x. The root is 3, the power is 2x to the 2/3 power. All right, so what can I do with this thing? Let me erase some of these lines I put in here. Go away. Okay. What can I do next with this thing?
Move the exponent to the front.
Yeah, take the exponent out front. So it's half log base 5 of x. Bam! And I just put 3 here, just make sure everybody's paying attention. 3 should be easier than 2. You got to notice what level everything is on. Do you see how 3 and 2 are different? What's inside the logarithm and what is that being raised to? What's inside the logarithm?
W.
No, careful. This is like this. Or even, let's make it more specific. This is like that. So that base is a part of the function. That number is a part of the function. And then I put stuff into it. So what's inside the log? What's the base of the thing inside the log? E.
E.
And what power is it being raised to?
The square root of r.
Good. So I can just take that down. You guys see that? Do you see the difference? This thing, the main thing was the square root. Holy shit. So I got to rewrite that so it has a power. So then I can take the power down. That's the power. I just take it down. Okay, maybe. So the property here for the power rule is if I have log of something and that thing in it, the thing inside the logarithm is being raised to a power, I can take that power out front. And that, of course, is one of the more powerful properties because it allows us to solve equations.
Powerful property.
Powerful property. Now, I don't know. I have even more practice here that I forgot about, to be honest. God, Lord, I have practice stuff everywhere. So I don't know. Let's see. What should we do here? Let me consider what to do. So I've got the practice quiz, which is a little more general. And then there's a little bit of stuff down here. Yeah, let's do this. Let's do this. And then we'll look at this. And then I'll do the change of base formula. And then it's probably going to be about time to go, I think. So that's basically what I was planning on doing tonight. We're a little ahead, to be honest. So we're doing pretty good. So can everybody see this? Everybody grab this off of Canvas? Or is this on Canvas? Let me make sure. Did I actually include that? Yes. Okay, good. Thank God. I was trying to remember if I, okay. So how do I do this? Number 1 and number 2 sound very similar.
Y equals 3 to 10th power.
Yeah, so this will be the base. 3 to the 10th equals y. I like it. So now you guys try number 2, and don't say anything. It's doing this thing. It's doing what we just did backwards. Maybe I'll do that. Yeah, maybe I'll do that. Sure. Okay, so it's always a little bit harder to go from exponential to logarithmic form. So you throw a log down. And you know what the base
7?
is. Yeah, the base is 7. I like it. Then what I normally do is I say the output becomes the input And what's the answer to a log always?
The exponent. Yeah, a power,
Like,
W.
there you go. So then you can check yourself. 7 to the W equals 5.6, check. And I really want to make this, I didn't really write this very well, but I want to show you guys, you never say log 7 to the 5.6. You don't read this as log 7 to the, no. The 7 is down, the 5.6 is normal, right? 5.6 is not a superscript. 7 is a subscript. So this is log base 7 of 5.6, the same way we say the 7th root of something. I like it. I like it. All right. I just lost somebody. I know this is not the most exciting stuff. All right. So you guys, look, do number 3. I'm just going to see here. Don't say anything. Do number 3. This is really good review stuff. I think at least one of you guys has already done this. So you just hang out for a little bit. Let's see, these first 4 have to be fast, have to be quick. The next 4, some of them are a little bit free. I'd say these 2 are the freakier problems. These 2 actually should be very quick. All right, you're all like, that did not help me, Jeff, but oh well, I'm just telling you the way it should be. Okay. Can somebody tell me, let me attack these a little bit different way. Can somebody tell me exactly which ones directly deal with inverse functions? Let's see who understands that question. Did anyone do any problem where they just crossed some things out and then wrote what was left? That means you used inverse functions.
A few of them.
Yeah, so somebody's telling me part G, I agree. Part B, I agree. That's 2
D.
of the 4. All right, so I got B, G, and D. That's 3 of the 4.
And I was looking at that. I'm not sure.
Yeah, so you have to rewrite that one, and then it becomes just like part G. So let's look at those real quick. Part B is quick. What do you do with part B?
Just take pi.
Die, and then pi. Okay, I like it. Right, ln and e want to kill each other. That's what they exist for. They're like antimatter. They just annihilate each other. Same thing with part D, 10 to a power and log base 10. Is everybody see how that 4 is on the same level as log? Do you understand what I'm saying? So what's the base of log? It's understood to be 10. So 10 to a power and log base 10 of something are inverses of each other. They kill each other. So the answer is 4. Done. What about part G? Part G is even more direct. Die. Done. Right? Another way to look at it, what power does B need to become B to the 8th? Well, he needs a freaking 8th power, of course. Right? Okay. So that's another way to kind of look at it. And now H, how do I rewrite the inside? We just did a problem like this.
To the 1/2.
Good. These kill each other, so the answer is 1/2. So that's the power. You didn't even necessarily have to do that. The power 11 needs to become square root 11 is a 1/2 power. Okay. How's everybody? You guys okay out there? All the people I can't see. All the boxed people. Where do they all come from? Okay. What about this guy? This one shouldn't be too horrible. You're really just asking yourself how many 3s multiply to be 81.
4.
Yeah, because 2 3s is 9. Another 2 3s is another 9, and that makes 81. Part C is quick. Log base almost anything of 1. What
0.
power? Yeah, you need a 0 power to make anything become almost anything. Got to be careful. Become 1. All right, now let's slow down on part E. Did anyone who hasn't said anything yet, does anyone think they got part E? Anybody that hasn't talked to me at all?
4.
Say again, sorry.
4.
Okay, now let's analyze what you're saying. If the answer to this was 4, then you're saying that 16 needs a 4th power to become 2. So go ahead.
1/4.
Good. I love it. It's the other way around, right? It takes 4 2s to make 16. So therefore 2 is 1/4 of 16.
Gotcha.
I like it. So you actually could you could do anything. You could say, okay, log 216 would be 4. So log 16/2 would be 1/4. You could actually do that anytime you have a base that's bigger than the inside. And they're kind of related, like 16 and 2 are related, obviously, right? So what's log base 81 of 3? Man, I thought we were all together on this. What's log base 3 of 81? Yeah, it'd be 1/4, the same idea. Yeah, right? Because I just turned these around. Ba-da-boo. So how many 2s make 16? 4. So 1/4 of 16 multiplicatively is 2. Now watch this. Watch this shit, kids. So what's log base 16 of 8? All right, I can piece this together. 1/4 of 16 would be 2. And then what would I do to 2 to make it 8? I would cube it. So there you go. It'd be 3/4. Do you have to do it that way? No. No, you don't. You could do like this. You could say, I don't know what the answer is. So 16 to the x equals 8. You can rewrite each based on 2. We've done a few of those problems. You could do that anytime. It's a little bit freaky, really. So now watch. Let's see if you guys get this. Your answer to part E was 1/4. What must your answer to part F be?
The
How do
negative
I-
of that?
Say again, sorry.
The negative of that?
Yes, because to get a 2, I need positive 1/4. So to make 16 become 1/2, I have to do the reciprocal of what I get with 1/4. So it'd be negative 1/4. So 1/4 power makes 16 become 2. So a negative 1/4 power would make that one extra step to make it become the reciprocal. All right, maybe. So you reformat the way you look at logarithms, and you make yourself realize the log is just asking me about powers. So I have to analyze them from a standpoint of powers, thinking about what power is required, because that's the question logs ask you. You don't have to memorize a whole new slew of things for log. No, it's an old shit. It's just kind of repackaged. Just saying, what power do you need here? I'm like, all right, maybe. All right, this problem is just making sure you can use your calculator. to do these things? Does everyone know how to do each of these things in your calculator? In your calculator? Shit. Hold on. Wait, somebody's chatting at me. I can't handle all this. Yes, you do. Okay, good. So what do you get? Can anyone do 3 to the 2.16? What do you get for that? That one should be easy.
10.73.
Yeah, 10.73. And I said, beautiful, 100th place. I'm going to try to remember to tell you what to round it to. Otherwise, you're like, I don't know what this guy wants. Because most of these are going to go on forever. So, you know. Do you guys see where your LN button is? Whatever kind of calculator you're using. Let me know if you don't see it. And I could try to help you out. I don't know what I'm doing there. What does somebody get?
4.71.
Yes, 11. 4.71. And on the face of your graphic calculator, if you have a graphic calculator, you should see the ln, you should see the log. So this is kind of coming back to the question I think Jordan had about what do you do for, can you plug in log base 7? So we're going to talk about that in a minute. So to do log of 0.4132, it's the same thing as natural log. I just hit the log button. So what do you guys get for log of port? Holy shit, Jeff. What kind of day have I had? I can't talk. Log of 0.4132. What do you guys get?
Negative 0.38.
Yes, cool. Now, did anybody have any trouble with any of those? All right. I'll take you at your word. So here's what I think I'll do. What time is it? Yeah, let's do this. Here's what I'll do. I'll make a solution video for this, right? So I want you guys to, obviously, number one important thing is to finish homework. But I'll go ahead and make a solutions video for this, and we can talk about it tomorrow also, right? All right. Yeah, so good. So then let's talk about this other thing that I was teasing. This change of base formula. Okay. I'm gonna have to get off my ass. Damn. Let's see. Let me turn off my show your work sign. Oh yeah, I was a blobfish the other day. Blobfish. All right. Cool. Have you ever done like a Google Doc and you're like an anonymous animal? Does anyone know what I'm talking about? No? When you sign into somebody
Yes.
else's Google Docs, it says you're an anonymous zebra or something. So the other day I was an anonymous blobfish. So I just made I made my background a blobfish, and then I made a little voice for him, and that's how I did the rest of the meeting. It was kind of, it gets me through. So this is really cool. So this is called the change of base formula. Sounds exactly what we need, because apparently, at least on the face of my calculator, I only see log and ln, right? So log of something, ln of something. So if I have log base 7 of 3 equals, I don't know, I want to do this. And it says, do this in your calculator. And you're like, I don't know. So what is the answer? I love this question. What's the answer? So let's all pretend like we're in algebra. We are in college algebra, to be honest. So what do you do when you don't know the answer? You call it
X.
X. Okay. So how can I rewrite this?
7x equals 3.
And now, does anyone remember what you can do to solve this equation? Now, you could just go straight back here, but that's where the problem was. What do I do to both sides that's going to bring that X down? What do most math people use because we're lazy? What function has the property where this will come down.
Square or
Huh? No, no, no. Say again. I heard it.
Log.
Yeah, logarithms. I mean, that's right. I mean, isn't that the thing we're just talking about? How can I rewrite natural log of 3 to the a? Can't I take that down? Right? So if I take the natural log of both sides, okay, that'll come down. Divide by natural log of 7. So x is this. Now watch. Now don't worry. We're gonna eliminate this work. This work is gonna go away. We developed a shortcut. So what is x? X was what we wanted to know, right? So let me replace that. What did we figure out x was? We figured out it was natural log of 3 divided by natural log of 7. Did it matter? Couldn't I just make that a 6 and that would have propagated? I could make that a 38 million and that would have propagated. Do you guys understand what I'm saying? Does it matter that there were 7 and 3? No. So how can I always rewrite a log base anything? I can write it as natural log of the inside divided by natural log of the base. You got to love it. Base on the bottom, base on the bottom, right? You got to like that. Okay. You don't have to. You could put up with that. I'm sorry. Okay. And this you could put in your calculator. So go ahead and do this. What is it? I don't know. My calculator's dead. I can't find the charger. My poor calculator. I have my fake calculator here on the computer. Let's see. Natural log of 3. You got to use these stupid parentheses. I love it. Divided by natural log of 7. So you got to be careful. Let me know if you get the answer. Give me hundredths place. So why can't we just put in log base 7 of 3? We actually can. I'm going to show you in a minute, but I just want to show you change of base. And then I'll show you they've hardwired. I think they have a place where you could do any log. I have to go and see if I can remember where it is. Let me see. Is it in here? There it is. I found it. Yeah, I'll show you in a minute. I still want you to see change of base. Yeah, 0.56. So real quick, before I show you the ultimate shortcut, do this for me. And then I want to show you a proof of something, and then I'll show you the shortcut. What is log base pi of square root of 14.9? My guess would be it's almost 1. That's neat. Square root of 14.9. How close is that to pi? It's probably a little more than 1. My guess would be 1.1. Probably way off.
1.18.
Holy shit. All right. Sorry. At least part of my brain, my math side of my brain is working. My talking side is not doing good. All right. So how would I rewrite this? What goes on the bottom? Natural log of the base and natural log of the inside. So yeah, when you throw that in the calculator, you should get what Rio said. Does everybody get that? You guys okay out there? You got to be real careful with parentheses and all that kind of shit. Okay. Just seeing if I get, come on, you could do it, Jeff. There we go. So you go, yeah, see, and I wasn't careful with my parentheses. So. There. So natural log of the square root of 14.9 divided by natural log. That's the problem. There we go, Jeff. This is exciting. There it is, 1.18. I like it. Chumbawamba. Now, one other thing. Do this for me. Do log of this divided by log of this. Trust me. Try to do log of the square root. Shite. What just happened? There we go. Why am I doing it? I know what the answer is going to be. Why am I? I don't know. Just do it. Did anyone do that yet? Anyone try this?
Same.
Same answer. Same answer, right? Of course it's the same answer, because remember when we were doing this thing, right? And I chose to do ln of both sides. Couldn't I have chosen to do log of both sides instead? So that's really trippy. I really want you to understand. This is a side note. This is a side note. But this says that the log base anything of something divided by the log base anything of something else is equal to the log base something else of that thing over the log base something else of that thing. I don't know if that even makes sense to you guys, but it actually doesn't matter which logarithm you use. The ratio of the two logs is going to be the same thing. And that's kind of a side note, so don't get too stuck in that, but that's an interesting side note. All right, now let me show you. Oh, let me do the official formula real quick, because I haven't really written that up here. So if I have log base b of m, that's going to be log base m over log b, or natural log of m over natural log of b. Why do we use log? No, Jeff, you can do it, buddy. There it is. Why do we use log or natural log? Because those are the two that are on the face of my calculator. They're on the front of my calculator. Now, there is a function under the math button. Let me show you. There is a function. Woo-ha. If I go to math, no, Jeff, don't do second. Go to math, and you got to scroll down or up a little bit. Where'd it go? There it is. See log base. Now, I'll be honest. I don't think I've ever used this. So, oh, good. Look at that. Holy shit. I had no idea what it was going to look like. So if I do log base 7 of 3, that's what we got earlier, right? 0.56 stuff. Okay, I like it. What's it look like in the older calculators? Let's see. Oh, you have to do log base and then base comma argument in the old calculator. If you have something where the square root symbol doesn't grow or stuff, it's going to look like this. Now,
Isn't
if you
that
have
the
a
other way
newer,
around?
sorry, go ahead.
Wasn't the base 7?
Oh, did I turn this around? So maybe that, yeah, okay. So it was log base 7 to 3. You're right. So apparently the input is inside comma base, which is the opposite of what I would expect, but oh well. So I'm sorry if you have an older calculator, it's too bad. If you have a newer calculator and it shows up like this, hit your mode button. If you have something that says math print, that's the newer approach. So that makes things look more like they would if you wrote them down on paper. Okay. All right. Oh, see, I'm not as interested in that because I don't need that shit. I got this shit. I'm good to go. All right. Anyway, I think that's all I wanted to talk about tonight. Yeah, that's not bad. Okay, that's perfect. All right. So a little bit of review night. We got the practice quiz that's up there. Tomorrow we can talk about it. I'll make a solution video for it tomorrow. So Thursday is the quiz. Over the weekend, I'll put the practice midterm up. I'll have a solution video for it next week. And then Thursday's the midterm. And then we get a nice week off. So Jeff can put off grading everything until that weekend and then go, oh shit, I got to grade everything. Damn. All right, so let me know if you need to hang out, if you got any questions. Otherwise, you are free to go. So let me know.
Have a good one.
Yes, you can make corrections. Somebody was just texting me or chatting to me, whatever. The midterm you can make corrections to. The only thing you can't correct is the final, the appropriately named final. See you guys. Everybody's good? I'm going to head out. Bye, everybody.